where the electrons go.
Electron configuration.
Electron configuration. And the reason we're talking about this is because I want to be able to tell you the kinds of ions that the blue metals find. Could you grab the periodic tables and hand them out, please?
Oh yeah, do you want to come over here?
All right. So see here, this is a big shot of the nucleus up in the right corner here, and it's just a pretend nucleus, right? See right here? You guys all see this?
Yeah.
You can go play, Tom. You don't have to be here if you don't want to. Okay. So here is a big, huge clump of protons and neutrons. Okay.
Which element is that?
No, it doesn't matter. And then I shrunk it down here so it's in the middle of this atom that I'm making. Okay?
Oh, that's an electron. That's one electron.
And that little negative sign there is an electron. And watch, see it moving around?
That's actually what's happening. It's
Well,
not
kind of.
just saying one-
It's moving around in this spherical track, on the spherical region, which we call the what? An orbital. An orbital. And how many electrons did we say are in each orbital? Two. Okay? So here's a second orbital. Here's a second orbital. 2 electrons going around in this orbital. There's 2 there now. Now, the next orbital. What does it do?
It does the same thing.
It goes on a different ring.
A different ring. So here comes the next shell.
No, that's
Next
not
shell.
the next.
It is.
Wait, no, I thought.
So
I thought
this
you had-
this first
I thought
shell.
you had
Hold
two
on.
circular
Use
shells.
your ears now. This first shell is the first row in the periodic table. Can you see the first row in the periodic table?
Yeah, it's the
Look at the
hydrogen.
periodic table. The first electron was hydrogen. The second electron was what?
Helium.
Helium.
Yeah, I noticed yesterday. I was 1, 2, 3, 4.
Yes. The next row is going to allow us to go all the way from lithium to what?
Neon.
Neon. From lithium all the way to neon. Can you see on your periodic table? Show your neighbor on their periodic table where the next one is going to go from. Lithium to neon. Lithium to neon, right?
Wait,
So,
no.
so to go from lithium to neon, we need to bring in the second sphere and then also those P-shape or those dumbbell-shaped orbitals. So here it is. Here's the second sphere. See right there, it's spherical. And then we have 1, 2, 3 of these dumbbell-shaped orbitals.
Isn't there? Oh,
Added the electrons.
So here comes the next electron. Wait, first comes the axis so we can see it a little bit better. Here's the next electron. It's right there. Ready to make it spin? Now it's going around this second spherical orbital. The fourth electron goes where?
In the second sphere.
In the second spherical orbital also. So here it comes. There it is right there. And boom. Now it's zooming around. How many electrons do I have in here now?
4. You have 5.
4 electrons. We've added 2 into the small sphere, the first one. 2 into the second sphere. The next electron's going to go where?
In the 2D.
Here it is. You ready? It's going to go into this orbital right here. So we push it again, and there it goes. Now it's flying back and forth into this orbital. 5 electrons. What is this thing?
It is
what is 5 electrons?
boron.
Boron. All right. The 6th electron.
Same thing.
There it is right here at the bottom here. See it? It's going to go into this orbital.
Wait, I thought the 6th one filled up the first one.
No, it has to fill up a different one first. A different one. Okay?
Is it spinning yet?
Not yet. Here we go. We'll make it spin. Now we got 6 in here. All right, that's carbon. The next orbital, next electron goes where?
That side.
Here it is, right here. Right? Here it goes. It's spinning around. Now we have 2 spinning in the first sphere, 2 spinning in the second sphere, 1 spinning in this P, 1 spinning in this P, or with this dumbbell,
We're at
and
nitrogen.
another one spinning in this dumbbell
We're at
right here.
nitrogen,
Where would the next electron go? Yes, at nitrogen. Where would the next electron
right?
go?
Back in the first one.
Yes, the next electron,
Go to the
whoops,
first dumbbell.
would fill into another one of these dumbbells. And then the next one, second one, and the last one, neon, would fill it up.
Yeah, can we do it?
Alright? It's happening right now, but it's so confusing you can't tell.
I didn't realize it was already happening.
Now,
Dude, just look at
Now.
what
what did we have to do to be able to look at the third shell?
you have to add that one.
We needed to shrink it, right? So now we're going to shrink it. So here it is, first shell, and then here's the second shell. All right. And now we're going to bring in the third shell. Third shell.
Wait, does it still have all the electrons?
No electrons in it right now. The third shell has a spherical thing,
A spherical.
spherical shell, and then it has three dumbbell orbitals, and then it has,
Really?
yes, lots
Can you
of
record?
d orbitals. Okay, so there's the spherical one there,
And then
there's the larger dumbbells, and then there's these other orbitals, which are called d orbitals, or the heavy metal orbitals.
And then there's the.
So we can have electrons all over the place.
Pew 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 pew.
All right, the donut in the middle. You can't hardly see it here.
I can. You can't. You can only barely see the nucleus anymore.
Is that the biggest it gets, Dad?
No. We get the fourth shell, because the fourth shell is the fourth line of the periodic table, the fifth line, and the sixth line,
Wait. I think.
and then the seventh line.
Wait, I
Right?
think we.
Can we see the seventh one?
We do
I
that.
don't go any further than this one because it's just too
Don't we?
confusing.
Don't we do the same thing for the next one down?
Next row down.
And but then after that one, then I want to go on to the lanthanide.
Okay, so that's a reminder of how these electrons stack. Now let's go back just a little bit and think about this. Tell me when we get to a noble gas, okay?
Okay, we finished.
One electron,
Pretty.
not a noble gas, right? This is
Hydrogen.
second electron, it's a noble gas. It's a noble gas because we finish the row is
shell.
called the shell, right? So yeah, it's also finishing a subshell, but it's finishing a shell also, right? Because in the first row, there's just one subshell and there's just one, it's the only thing in the shell. The second shell reaches a noble gas when?
Twice.
When when the whole thing is completely full. Now Tim, which is all the way to neon. Now Tim, as you said, it finishes twice. What he's probably referring to is filling up beryllium and then also filling up neon. And
Yeah.
it's true that beryllium has a certain amount of stability. So when you fill up beryllium, your element has a certain amount of stability as well. And then the next step in stability comes actually before the noble gas. It comes when you get to this point right here, where you have a full
It's making
first
me dizzy.
sphere, a full second sphere, and then each one has one electron at nitrogen. So nitrogen is slightly more stable than oxygen. And
Yeah.
that's kind of why when we breathe, nitrogen, I mean, if you light a fire, nitrogen doesn't burn. Nitrogen gas doesn't burn, right? When you light a match, what's burning? The oxygen's burning. Okay?
Wait, but I thought nitro was like super explosive.
Things that contain nitrogen can be explosive because it produces nitrogen gas, which is very stable. And so when something that's not stable produces something stable, it releases a lot of energy to the surroundings in the form of heat. So that's why things that contain nitrogen are explosive, because their product is what? Nitrogen gas, which is very what? Stable. So whenever anything that has a stable product, the process can release the energy. So we find stability in atoms when we fill subshells and when we fill the whole shell, which we get to the end of the row, right?
Yeah, and then also, you get to phosphorus, because you do that twice, I think.
Mm-hmm.
So you get to phosphorus, and that means it goes in all substrates.
Yeah, there's a degree of stability. A degree of stability.
Good.
Now, when we're bringing in the third shell, right? We bring in this third shell here.
Yeah, it is.
It has, again, the S, the spherical, the dumbbells, and then the crazy ones, right? Now, I've been calling them spherical, dumbbell shapes, and crazy ones. But the real letters that they give them to abbreviate them to
3P, 4P,
S,
2.
P, D, and F. S, P, D, and
What's N shells?
F. What?
What's N subshells?
And subshells? I'm just showing that the first row, you have that number, N number of subshells, which is 1, and that's an S. The second row, you have 2 subshells, S and P. Third row, 3 subshells, S, P, and D. Fourth row, 4 subshells, S, P, D, and F. Don't bother. Okay? Does that make sense?
Oh, yeah. So you get calcium's also stable.
There's degrees of stability, all right? Stable-ish. And in fact, it's not very much because we know calcium likes to lose 2 electrons and become like a noble gas, right? But now, did somebody hand me a periodic table? Where did all of them end? Here they are, I got one right here. So now we can look at this periodic table and make predictions about what kinds of ions these blue elements will form. Okay? The blue elements. All right, now let me, you guys come back over here now. Tim, you come over here.
David, I got a great shot of your face.
Let's draw the electron orbitals for titanium. Titanium. Let's try the electron orbitals for iron. For iron. Okay? Let's draw the electron orbitals for iron. So we're going to draw an atom of iron. Here's the nucleus.
Nucleus.
What comes first?
First shell. S.
A 1s. A 1s. The first row,
1s.
and it's spherical, right? How many electrons are in it?
2.
2 electrons. Can you say 2 electrons per orbital?
2 electrons per orbital.
Very good.
How many
2
electrons
electrons
are
in that orbital. And that's a 1s.
Aaliyah.
What's next? What's next? Now, when I say what's next, what you guys should do is look at the periodic table and find out. Here's a hint. Look at over here. All of the s orbitals are in this box here. All the p
Helium.
orbitals are in this box here. All the d orbitals are in this box here.
And then all the F's are right
F's
Helium.
are in these boxes down here.
And then all
Get
the
the periodic
F's
table
are right here.
All right. So the first one is an s with 2 electrons. The next 2 electrons, where do they come in?
The next 2 come in lithium and beryllium.
At lithium and beryllium. Is that an S
That's an S.
spherical shell? How did we know?
Because those 2
Because
are.
this box over here are spherical shells. All right. So we have a second spherical shell, and it has 2 electrons. What's next?
P.
Beryllium through neon, right?
P.
Beryllium through neon. 3 dumbbell-shaped orbitals, correct?
Yep.
3 dumbbell-shaped orbitals. How many electrons can it hold?
6.
6 electrons. All right. So we have, I'm going to write this up here. We have a 1s orbital with 2 electrons.
30 more
that?
seconds.
See this, guys? Pay attention. I have a 1s orbital with 2 electrons, right? And then what do I have next?
Less now.
A 2s with how many? 2 electrons. And then I have what? Not a 3p, it's only on the second row. So it's a 2p. And how many electrons can I fit in there? 6. You can count across. You can count across right here like this. 1, 2, 3, 4, 5, 6.
5, 10, 6.
What's that? So 2p, 6. What's after 2p? What comes next? After neon? Third shell.
3s.
3s. And what electrons are those? What elements would those be?
Sodium and magnesium.
Sodium and magnesium. How many in the 3s then?
2.
Dad,
3s, 2.
it's time.
Time?
No.
Oh yes, it is time.
No.
Well, we'll have to stop right here and pick up drawing iron, what it looks like next class. You guys are almost done for the year, for the summer. See you later.